When we look at the types of triangles, there's different names, there's several different names for triangles. One of the namings is based on their angles, and the other naming is based on their sides. So we're first going to look at names based on the angles of triangles. Alright, based on the angles, we have three names of triangles that we're going to look at: acute triangle, right triangle, and obtuse triangle. We've already looked at the names of acute, right, and obtuse in terms of angles. So an acute angle, a right angle, and an obtuse angle. Now we're using those same words to name triangles. An acute triangle is a triangle where all three of its angles measure less than 90 degrees. Okay, so all the angles measure less than 90 degrees, and that little symbol I'm using there is a less than symbol, not an angle symbol. They look very similar. An angle symbol, it goes straight along the bottom, but regardless, based on context, hopefully you know I'm using a less than there. And this is just a shorthand phrase to say that the measure of all the angles is less than 90 degrees in an acute triangle. And so we'll just sketch in a quick example of that. A right triangle means that there is one angle that equals 90 degrees. So if we have one angle equaling 90 degrees and there's a total of 180 degrees in a triangle, that means the other two are going to have to be acute just for it to be less than 180, equal to 180 degrees. So that's the idea of right triangles. One of those angles will be 90 degrees. By consequence, the other two have to be less than 90 degrees. And then lastly, an obtuse triangle is a triangle where one angle is greater than 90 degrees. Alright, so, and I try to sketch in what that would look like there. So if you kind of zoom out on this, essentially we're always going to have two angles that are less than 90 degrees. In an acute triangle, they're all less than 90 degrees. In a right triangle, that third angle is a right angle. In an obtuse triangle, that third angle is obtuse. So those are the three names based on the angles. Now we're going to switch and do three names based on the sides. So it's three totally different classifications. Alright, the three names based on side lengths are isosceles, equilateral, and scalene. An isosceles is a triangle where you have two of the sides are the same length. And when you have two of the sides the same length, because the length of the sides is related to the angles, this also means you're going to have two angles that are the same. Now, as far as drawing one of those, this is where we go back to using our tick marks to indicate that those sides are the same length. And then you don't have to show this, but the angles that would be the same would be these guys. Those would have to be the same. That kind of looks like an angry little monster triangle, but that's just what I'm seeing. Alright, so let's move on to equilateral. An equilateral triangle, remembering that the word lateral means sides, side is a triangle where all its sides are the same length. And because all the sides are the same length, the consequence of that is that all the angles are the same as well. Now, even though right now we're doing the classifications based on side, the fact that side lengths is related to angles, this tells us that an equilateral triangle is also going to be an acute triangle. Because if all the angles are the same, you take 180 degrees and divide it by 3, those are going to be less than 90. They'll be 60. Alright, so there's an equilateral triangle to the best of my ability. Not perfect, but I think it's pretty close. But you use little tick marks to say that what you mean, even if you can't get it drawn the way you want it to draw. And these are all going to be 60 degrees. The angles will all measure 60 degrees because they'll all be equal. I guess I don't need a tick mark for that, but anyways, we'll do this. So that's going to be 60 degrees, so will the other two. Alright, so our third one, based on sides, is that all the sides are different lengths. A scalene triangle, all the sides are different lengths. And then, of course, as a consequence of that, that's going to mean that all the angles are also different. Try to draw one of those. Okay, there is a decent scalene triangle. Scalene's easier because it they just have to all be different. It's harder to make things equal. So as far as drawing them goes, it's easier, I think. Now before we go on, I want to emphasize something that's happening here just to make sure everybody's tracking. An isosceles triangle has two sides of the same length. An equilateral triangle has all sides the same length. What that means is equilateral triangles are also isosceles triangles, because if they have three sides the same length, that means they have at least two sides the same length. So just throwing that out there, that kind of like a square is a rectangle, but a rectangle is not necessarily a square. Well, an equilateral triangle is an isosceles triangle, but an isosceles triangle is not necessarily an equilateral triangle. That's a mouthful. Alright, so those are our names of triangles. We have 6 total names, 3 of them based on the angles, 3 of them based on the sides. Now we're going to change gears entirely and talk about something called similar triangles.